Suppose we're given the area and are asked to find the z-score. In the table, we find the closest area and find its corresponding z-score. So what we're doing here is, compared to the past, where we were given a z-score and then looking up the area in the normal curve, now we're going backwards. Okay, so an inverse normal curve, we're going backwards, basically saying we're going to be given the area or probability, and we want to use that to find the z-score. Okay, so in the calculator, we can do second bars and INV for inverse norm. You put the area, comma mean, comma standard deviation. Okay, so graph each of the following and find the z-score that has 0.7357 to its left. Okay, so what we'll do is we'll draw the curve. Now you can also see the next one, 99% to its left. I have that drawn there too. Okay, and what we want to find is what z-score has 0.7357 to its left. So what we do is we go to the table and we find 0.7357 in the body of the table, because that we're given the area and now we want to find the z-score that goes with it. So 0.7357 we notice is right here. It actually shows up in the table, and we get 0.6, and then it's in the column 0.3. So 0.63 will be that z-score. Okay, for the next one, 99% area to its left. So you're going to look up 0.9900. Okay, so 99. Okay, there's a lot of 99s down here. Okay, 9900. Well, here's 9904, 9901, 9898. So you think about which one are we closest to? We're closer to 9901. So that is 2.33. And if you have an area that's not exactly in the table, you find the one that it's closest to. If it's exactly between two values, then you average the two z-scores together. Okay, the next one, 0.1350 area to its right, and then the one next to that, because I'm going to show you the answers here. 54.62% to its right. Well, 54.62% is the same as 0.5462 without the percent, because you move the decimal 2 places left if you're given a percent. Okay, so now we're looking at area to the right, which is different than to the left, because now we're shading to the right. Okay, so this is what they would look like. And if there is 0.1350 to the right, remember that when you look it up in the table, it's telling you the area to the left. So if you subtract 0.1350 from 1, you end up with 0.8650. So if you look up 0.8650, okay, 0.8650, well, here's 8643 and 8665. So 8650, so 8650 is closer to 8643. So our z-score will be 1.10. Okay, so that z-score is 1.10. Okay, and for the 54.62 to its right, there you'd want to look up 0.4538, and you can take my word for it, you get negative 0.12 for that z-score. Okay, now if you want to find these using the calculator, okay, if we follow the directions of second bar's inverse norm, okay, so I'll just find, let's find part B up here. So second bars for the distribution. And now we want to do inverse norm. So that's the third option down. Okay, we'll put in the area, which is 0.9900. Now your calculator is the default that you're using, the standard Z. So if you press enter, it should give you the correct Z-score. But if we use the actual mean and standard deviation, okay, so mean comma standard deviation, the mean of the standard normal is 0 and the standard deviation is 1. Okay, and then if we press enter, we get 2.326, so that rounds up to 2.33. Okay, so that's how you find on your calculator the z-scores given the area. Okay, remember you have to put the area to the left in though. Okay, so that's inverse norm 0.9900 and then 0, 1. Okay, next one, 50% of the area between negative z and positive z. And then in part G, 95% of the area between negative z and positive z. Okay, now what we have to recognize here is that negative z and positive z are the same z-scores except one is positive and one is negative. Essentially saying that one of the z-scores is on the left side of the mean and the other is on the right side. Another way this can be worded is you're looking for the middle 50% or the middle 95%. Okay, so we'll draw our curve, and it's going to have the percentages on there, which I'll talk about in a minute, or the decimals. Okay, so the middle 50%, you have to figure out, well, how do we look that up in the table? Remember, your table gives the area to the left, and if you're in the middle, if you just look up 0.5, that means you have 0.5 to the left. Well, we don't have 0.5 to the left. We have 0.5 in the middle. 0.5 to the left would actually be a z-score of 0 because that's the halfway point on the curve. So if you looked up 0.5 in the curve, you would get 0. Okay, that is not the answer here. So what you have to do is you have to think a little bit and recognize that we have two symmetric ends with the same area in them. So the area to the right of this z-score is the same as area to the left of this z-score. So you have 50% left over to split between the two ends is 0.2500 on each end. So if you look up 0.2500, we're on the negative z-scores because we're less than 50%. So 0.2500 okay, here's 0.2578, 2500. It looks like it's between 2514 and 2483. Now, just ignoring the decimal point and thinking about the thousands here, 2514 is 14 away from 2500, and 2483 is 17 below 2500. So we're closer to 2514. So that's negative 0.6, and then we're in the row of the 0.07 up here. So negative 0.67 is that z-score. Okay, because of the symmetry, positive 0.67 will be the other z-score. And you might notice that if you look at the 0.5 plus 0.25, that's 0.75. If you were to look up 0.7500 in the table, you would get positive 0.67 for the z-score. Okay, and then for the 95%, similarly, 95% in the middle means you have 5% to split between the two ends. So if you divide 5% by 2, you get 2.5%, or 0.0250. Okay, so when you look that up in the table, you get negative 1.96. And then the positive z-score will be positive 1.96. Okay, next thing is looking at percentiles. Okay, remember that percentiles just tells you the percentage of the data that is less than a certain data value. So if you want to find the z-score that corresponds to P40. Okay, now that P40, that's the way you write the 40th percentile. So remember, all that means is 40% of the data is to the left of whatever P40 is. Okay, P90 means that you have 90% of the data to its left, and P99 means you have 99% of the data to its left. So we're going to shade 40%, 90%, and 99% to the left. Okay, and again, I'm trying to do this as quickly as I can, so if you need to pause the video, please do so, and try it on your own. Okay, so these percentile questions are really just a roundabout way or a trickier way of asking you to find the z-score that has a certain percentage to its left. So what z-score is 40% to its left? So when you look up 0.4 in your table, so 0.4000, okay, 0.4000 is between 0.4013 and 3974, but it's closer to 4013. So that's negative 0.25. Okay, so the z-score that has 40% to its left is negative 0.25. Okay, and there's the answers for the other ones. I suggest that you try those, looking them up in the table and find them. Okay, and then an example of an actual application of this. Going back to the wait times at a busy restaurant. If you don't remember, the mean for that wait time was 40 and the standard deviation was 6. So we want to find a wait time corresponding to P75. Okay, so what you do is you want to find what wait time is greater than 75% of all other wait times. Okay, so what you have to do is we have to find the actual wait time. Remember that wait time, and this is extremely important to understand, wait time is your x value, not a z value, but an x. So we have to think about, well, how do you start with an area of 0.75 and convert that into a wait time? Well, remember, if you have an area, or the decimal here, 0.75, you can convert that into a z-score. And the way you do that is look up 0.7500, just like we have been, and that'll give you a z-score of 0.67. Well, now, what always relates a z-score with a data value of x? It's always, every single time, z equals x minus mu over sigma. Okay, so if we have a z-score of 0.67, we're going to put that into our equation for z. We know the mean and standard deviation is 40 and 6. We can use that to find x. Okay, so we go ahead and do that. So you cross multiply, so multiply each side by 6, and then add the 40, and you end up with 44.02 minutes. Okay, the wait time for the middle 50%. Okay, so part B. Well, notice that 75% is related to the middle 50%. So if you add the 50 and 25, you get 75%. So it just so happens those z-scores, 0.67 and negative 0.67, are related to this last question. Now that's just coincidence that it worked out that way, based on what I asked you. Okay, so now we have to find the wait time for the middle 50%. Well, now we have two different z-scores, basically saying two different wait times. So you have to use that same formula, that same concept as we did in the last one. You have to do it twice though. One for the negative z-score and then one for the positive z-score. And then when you solve that, you end up with 35.98 and 44.02. Notice that's the 49.02 is the same as the last one. Okay, so here the wait time is between 35.98 minutes and 44.02 minutes. Okay, so the middle 50% of people, they waited between about 36 and 44 minutes. The last one, P75, that says that 75% of the people waited 44.02 minutes or less.